Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Thank you, Scarlett. Thank you, everybody. Thanks for having me here. I flew over just for this event so I could be with you today. Actually, I think Scarlett found out I was going to be in the UK a couple weeks ago and lined me up for this. So, I think Scarlett gave you a little bit of an introduction yesterday to Microsoft Research and specifically to our team, Microsoft Research Connections. But one way of looking at the sort of relationship of innovation and then technology transfer across the company has been this model that has never really worked the way that the diagram says it should work. But the ideal was to have core computer science research, Microsoft Research doing investigations and innovations into technologies where the event horizon was possibly 10 years out. And then within each one of the product groups, there would be a series of labs that would really operate as more of an applied lab group that would take some of these technologies or take ideas that had been born in the product teams and test them out. So Office has an Office Labs. The Live team used to have a Live Labs, and that's since gone under. Bing has a various number of labs around the world where they're doing a lot of investigations. And these people tend to move pretty easily between doing core information retrieval research in the case of search labs to very quickly transferring that work into the product teams, into production scalable services. Our team within Microsoft Research is not a research team, by and large. We are a team that attempts to take a lot of the services and operate more in that applied labs space. We do that within the realm of academic research. So we work a lot with domain scientists, and we try and marry up the needs of the research community external to Microsoft and some of the innovation that's going on within this building, within Redmond, within our Beijing lab, and in our India lab. So where this works really well is where we can build a strong partnership between the researchers in our labs and the needs of our community. So today I'm going to tell you a little bit about one of the projects that we're doing in this space. But we do this specifically with a very small engineering team. We have about 6 or 8 full-time employees. Occasionally we'll supplement that with 4 or 6 month long contract employees who will come in and help us on projects. And in a number of cases, we actually partner with universities. So if I've got time at the end of this talk today, I'll tell you a little bit about a project that we're doing right now with UC Berkeley and with Moscow State University, where we will sort of act as a mediator. We will project manage the project. We'll do a little bit of the development, but the bulk of the development, in fact, a lot of the scenarios are driven by what the researchers at these institutions are looking for. All of the projects that we manage within Microsoft Research Connections fall within one of these 5 theme areas, and I specifically work in the education and scholarly communication realm. And effectively what that means is trying to look at the entire research life cycle. Generically, what are the things that we can abstract out about everybody who's doing research? And then some very specific scientific computing projects where we get into very domain-specific things like chemistry, biology, astronomy, and other tools there. So specifically, I'm going to tell you about a tool that we've been working on in the discovery space here today. But first, I want a little show of hands. I want to understand you guys a little bit better. So you can vote more than once. I'm mostly just curious here. How many people on, let's say, a once-a-month basis uses IEEE Explore or ACM's digital library to look up content? Okay? How about DBLP? Great, about half of that. Google Scholar. Yeah. Scopus, Science Direct, fewer, and Web of Knowledge. Ooh, very few. Okay. And then similarly, when you get to paper citation management and paper management tools, who uses EndNote? Very few. Mendeley? All right. ReadCube. Anybody heard of ReadCube? Oh, one. Zotero. Interesting. Okay. So definitely a Mendeley crowd here. This is good to know. Are there other tools? Shout out. What tools do you use?
Hey, Jabra.
Jabra?
Papers.
The back. Excellent. Should have put papers on there. Okay, great. Thank you. Okay, so Microsoft Academic Search is our foray into this space. It is a freely available web search engine. It's at academic.research.microsoft.com. It's been something that we have been gestating for a couple of years, and it really had its start. Forget that. I'll come back to that in a second. It had its start in a project called EntityCube out of our Beijing lab. And EntityCube was an effort to look at documents on the web and try to construct a certain amount of entities and entity relationships using machine learning based on documents on the web. Microsoft and Google and Yahoo have been partnering in something over the past year or so called schema.org. Have people here heard of schema.org? It's a relatively simple markup. It extends HTML in micro formats. It is a very, very simplified version of what people are trying to do in semantic web with RDF, but it doesn't really address at all relationships. This is just marking up things on the web. You can say that this string in a web page is a person, and a person has a very simple schema. It can have a birth date, it can have affiliation, it can have a few other things. This is sort of the effort that the major search engines are looking to moving forward, providing tooling and providing ways for people to annotate documents on the web to say the thing that I'm talking about right here is a movie, or this is a book, and here's the author of the book. But what the EntityCube project tried to do is tried to do this all from an untrained set, just going out and looking at random text on the web and say, okay, here is a person. Person is David Cameron. He would fall into the realm of politics, and then starting to look at the different bits of information that you can pull out. Bring a browser here. So I'm going to go very risky here and try and do live demos. This is running on a, excuse me for 1 second. This is running on a server in the Beijing lab, and not a very robust one. So I may give up on the live demo if it's just too slow to run here. But you can play around with this tool. You can see what's been built into it. I can type somebody's name here. So I can type like Don Syme, and this will take about 10 seconds for the page to load properly. And what this will do is it will find Don Syme, and then it will present a number of tabs of different sorts of information that we found about Don Syme. Quotes that he has made, biographical information about him, related people, simply based on term co-occurrence in web pages. Who has Don Syme been mentioned with in documents on the web? And then starting to present some ways of visualizing that information. So who's he related to in a sort of relationship map point of view? Boy, this is brutally slow. Okay, I give up already. If you have more patience than I do, you can go ahead and play with that tool. I'm going to go back to the slides. All right. But this project, one of the other tabs that you get there would be a set of papers that we have found authored by Don Syme. And so there's two bits of entity recognition that are going on there. How can we find something that looks like an academic paper because it has certain features, certain characteristics, and then how can we start pulling entities out of that? What is the title of the paper? Who are the authors of the paper? How can we follow the various daggers and superscripts to say that this author came from Microsoft Research and that author came from the University of Cambridge? And we were really looking at this in the computer science literature, but we sort of peeled out a lot of that academic work and started saying, okay, can we turn this into a set of academic entities? Can we find the papers on the web that are research papers? Can we do a decent enough job of author name disambiguation and author integration? And then start pulling out things like all of the institutions and the variant string names for institutions, the various string names for author, so Alex Wade versus A. Wade versus A.D. Wade, and trying to cluster those correctly into a single author entity. And then we can start aggregating these things together up at the journal level and at the conference level. So that's what academic search is. It operates very much like a search engine. You get a search box when you get there. You can type in a query term. You get a set of search results. So I search for Donsheim F sharp, and I get a set of papers back. But in addition to that, very often you might type in a keyword, a thing that we recognize as a concept out of the literature, where there may be a number of variants of this, stemming variations, so faces detection, face detect, face detecting. And this is a profile page of this concept, of this keyword. We'll then pull out of the full text of the literature that we've indexed some definitions of that. So in this document, they're giving a more or less an is-a statement of what face detection is. And you can see the top authors, the top journals, and the top conferences where this term has appeared in the literature. The histogram in the middle then gives you a little bit of an indication. Now, that could be a reflection of the amount of content that we've indexed over time, but you can definitely see patterns in the literature where a new concept comes up. You can see, hey, people started talking about this thing in 2005, and you can see whether or not it's growing or it's tapering off. And then you always will see a taper off at the end there for things where there just aren't enough publications yet in 2012 or citations to those documents. If you click on one of the papers, then we offer that same level of profile information. So instead of just being a set of search results where you get 10 blue links and you say, yep, that's the paper I want, and you're off there, we try to provide a little bit of aggregated analytical information around the publication itself. So this is a paper. It was published in the journal Arthritis and Rheumatism. We'll pull out of the full text document the abstract, links through to the author pages. Because we are now not just pulling this content from openly available documents on the web, we are also going out to publishers and indexing their content. You may see multiple links here. This may exist on an author's web page. It may exist in an institutional repository. It may also be on the Elsevier or Springer or Wiley website. And we try and provide all of the options that we know about on the web. And we will aggregate together the author copy with the officially published copy into one record here. A few other things that we do is, just like we pulled the definitions out of the keywords out of the papers, in this case we're actually pulling out citation context. So we will have, farther down on the page, a list of all the papers that we know about that have cited this paper, and we'll pull out of the full text of those papers the bit of binding text that says why this person was referring to this paper. And then a few of the other things that you can do. For any one of the entities in our system, you can subscribe to changes to this. So if a paper gets cited an additional time, you'll get an RSS alert for that. We also crowdsource the editing of this data. So where we know of multiple versions of the records, we don't always correctly collapse and dedupe those records down into the same one. Or in the case where we're actually parsing a PDF, sometimes the string extraction can get a little bit wonky and we miss spaces. So we invite people to come in and edit these records. Anybody can do that. You currently need a live ID, although we're hoping to expand that to other OAuth providers. And that's mostly just so we can track who's making changes and try to prevent spamming of the system. But you can come in and you can edit the metadata on these records. You can also export it to other tools using, I think we have about 3 or 4 different formats that you can export out into EndNote and to others. And then down below you get a list of all the, as I mentioned, all of the references within this document as well as the papers that have cited this document. So the journal profile page, we just aggregate these things up for all of the for each one of the journals that we've indexed. Same sort of approach. You can see who the top authors are for each journal. You can sort all of the publications from a journal based on the number of citations or the year or time. And then probably one of the most popular features of the system, the number one thing that people do when they come in and play around with the system, is look at their own author profile, and or somebody who you know. And so in this case, we're actually doing some additional things. So we are actually going out and piggybacking on some of the web indexing that Bing is doing. And we try and locate things like the author homepage and a photograph of the author, and we'll automatically insert these into the record. We don't have photographs and homepages for, I'd say it's probably around 10 to 15% of the records in our system have those today. So we only do that in cases where we have a relatively high confidence that we've got it correct. So again, we invite people to come in and edit these records, provide a picture, provide a homepage, upload additional documents, and I'll show you some of that editing feature a little bit later on. But one of the other things that you can do around this author page is you can start then to see who this person's top co-authors are, what conferences they publish in, what journals they publish in, etc. So I'm going to go back out to live demo time, see if I have better luck here. Let's see, I'll search Carl Lugosi. No, I won't. And I will bring up his record. Not running much faster, am I? And if I jump into Carl Lugosi's page here, we offer a number of visualizations of this content. Not going to do live demos here. You can play around the visualizations later. But here's one example where we will show the co-authorship graph. And we'll take the top 20 or 30 authors that he publishes with most often, build a graph around this. You can click through and navigate through the graph. So if you wanted to click on Herbert von Nesample and see his co-authors, you can do that. The graph will repaint. If you click on any one of the edges here, it will show you the count of papers that those two people have published together. Similarly, we have a citation graph, so you get the same exact graph here, but instead of the people that they've written with, it's the people who have cited their papers. And then if you want to know your Erdos number or see the shortest path between any two authors, you can click on the co-author path link there, type in any two names, and that will show you that graph. So one of the two more entities to show you real quick, and then I'll get into some of the other features on the site. So what we do is we build up then an array of author affiliations. As somebody moves from institution to institution, we will store that timeline in our system, and we will then allow the ability to aggregate this, just like we aggregate all the papers together up to the journal. We can aggregate all of the researchers up, or all the authors up to an institution. So this is the institutional roll-up of the University of Cambridge. You can see the total number of publications that we have from Cambridge, total number of citations, and H-index, although Hirsch really defined that as being something around a person, number of publications and the number of citations. We calculate here an H-index for a journal and an H-index for an institution as well. And this is an old screenshot, but one of the other things that we are starting to show on this is self-citations. So you can actually see how many of the overall citations in one of these aggregate views are self-citations. Two other things that you can do with this information. You can start looking then at domain trending over time. So if you want to see how an institution like the University of Cambridge or Microsoft Research is changing over time, you can click into this domain trend, and you can pick a number of either the top-level domains or subdomains. So in computer science, if you want to see how Microsoft Research, for example, is producing research outputs in computer vision versus information retrieval, you'll see a significant increase in the number of publications that we've had in recent years, for example, in computer vision. And this is all of the subdomains right here, looking through all of the literature, and you can sort of see that when you go back to the early 60s, there were a lot more publications in natural language and speech relative to some of these other domains. And you look over here how artificial intelligence starts to rise up in the early 70s there. This can also be used as an information retrieval tool. So each one of these shapes over here is a clickable region, and there's a slider here. So if you just want to look at 2002 to the present and then click on artificial intelligence, the number of authors who are publishing in that area will filter down here. And you can do this either in aggregate across all of the literature, or you can do it for an individual institution. You can also start to compare institutions this way. So we don't provide a method for doing an all-up comparison, but if you drill down into a domain, in this example, we've done physics. Lost my clicker here. Where'd the clicker go? There we go. So the physics domain and the subdomain of atomic and molecular physics in the last 5 years. What this will do then is give you a graph of the publications that compare these two institutions, but it will also give you this sort of Venn diagram view here of the key terms that have come out of the published literature that are unique, in this case, to MIT, the ones that are unique over here to Stanford, and the orange in the middle are the area of the Venn diagram where those two term sets overlap. Okay, and the last of the entities that I want to talk about that we extract out of this, and this is much better in our current database for computer science than it is for any other domain, is, again, from pulling out of the web documents in the published literature, we're able to build up a profile not only of the conference and all the papers that have come out of a particular conference, but we can start to scrape out things like the call for papers dates. So you'll see here on this particular conference for Chi, we have the home page, but we also have this CFP link right here. And if you click through to that, it will take you to a page that will show you at least this year's, hopefully next year's, call for papers, when the final copy is due to the conference, when the conference start dates are. So this is an interesting thing if you go back and look at any of the conferences that you attend regularly and get a sense of who the top authors are at that conference over time. But you can also then use this as a way of looking for upcoming conferences. So you can come in here, you can pick the domain of conference that you're interested in, and the chart over here will show you the graph of when the call for papers is and then when the conference is. Number of bars over here indicates how many days that conference is. And you can slide this little slider around here to dictate when you want to travel. And if you're really interested in going someplace warm, you can actually click over here and say, oh, when's this conference in Hawaii? When's the call for papers for that conference? And I don't care what it is, but I want to go there. All right, so just some of the other tools. So showed you the search engine. I showed you a lot of the endpoints, the sort of leaf nodes on this graph. But a lot of the other research that we're doing right now are what are some of the calculations that you can do over the graph. First, for improving the quality of the data, you will still find a lot of times where the author disambiguation, we haven't gotten it just right. We take a lot of the end user edits into the system and we feed that back in. So a few times a week, we actually rerun all of the author integration algorithms. It takes right now about 48 hours to run. The graph that we currently have has roughly on the order of about 100 million nodes on the graph and about 500 billion edges. So we're doing a number of calculations there. The first pass is to try to identify high confidence authors or papers that we can start merging together, or areas where we may need to split them apart. Then some simple calculations like what are the citation counts? Each citation is an edge on that graph. What are the publication counts? What are the H indices for each one of those entities? And that's very computationally intensive work right now. So we're also looking at ways of speeding up those algorithms. Once we've done all of that, though, we can then start to do things like providing a browsable interface over this. So in addition to this being a search engine, you have the ability to come in and click down into, I'm in computer science here, go into a specific subdomain, and then start doing things like, who are the top authors in that domain? What are the top publications in that domain? What are the top journals? What are the top conferences? I don't have conferences in biology right now. But you can drill into these lists. You can also do this for organizations. So what are the top organizations in physics in Europe? And start doing organizational comparisons this way. And all of these will start to produce these ranking lists that you can slice and dice the information in a number of different ways. You can sort it by citation count, sort it by publication count, sort it by H-index, and sort of see how these trending data are going over time. So one of the interesting things that we started looking at was how is Microsoft doing relative to some of our peers in information retrieval, like Yahoo Research, over time. and in what areas of information retrieval are the two organizations investing. So this is sort of an open platform for competitive intelligence that we use with some of our competitors, but that universities can also use to see the aggregate view of their research. So I've talked a little bit about the editing functionality. This is the editing landing page. Like I mentioned, you do have to log in with a live ID, but these are the sorts of things that you can do. You can edit an author profile, so change the homepage, change the name. You can merge author records together. You can merge publications together. You can also provide us with additional links. So if you have documents, if you have your own publications that are available out on the web, or they happen to be in your university's repository, you can upload URLs to those PDFs, and we'll go out and fetch those and index them as part of the system. You can also just give us a BibTeX file. So if you want to feed us a bibliography of documents, we'll process that and add them into our database as well. The call for papers is where all of the conference data is. So in areas where we know about a conference but we don't necessarily know the CFP, those can all be edited. And one of the new features that we've just added in here is this author relation graph. And this is a genealogy graph that shows the relationship between advisors and advisees. And again, we're trying to parse this to the extent possible from mentions of advisor-advisee roles, either on web pages or in published documents. But you can also go in and say, this is my advisor, and that will also then show any papers that have been co-authored by you. Okay, so that's the website. Play around with it. Send me feedback. It's a work in progress. Like I said, this is something that we sort of stand with one foot in the research camp and try and look at ways that we can improve some of these algorithms, and the other foot really in we're providing a production service here. And we try and create a balance there so that we have a reliable, worthwhile service. We do realize that we only have about 40 million index publications right now, and we have a number of publishers who are providing us with access to their publications, but we're a small team and we're just processing through that queue. So if you look at the site and you say, hey, you're missing my publications, use the editing tool if you want to see them get in there more quickly, but also be patient with us as we add more content into the index.
So Alex, 40 million papers, for example, Google Scholar, how much would they in comparison?
That's a good question. Google Scholar is not very transparent in terms of who they index and how much content is in their store. I believe that they have more than 40 million. They probably have double that. They also index patent information and case law information in their index. But I'd say, if you want an order of magnitude, I'd say we're probably at about 50%. We are trying to be very transparent in what we're indexing. So if you go to our help page, you'll actually see the list of publishers who have provided us with content. And like I said, we're getting through that. Do you have a microphone, Scarlett?
Hi. Do you guys have like a section for organizing your papers, like in the way as Mendeley, or so if you want to, like keep record of all the papers you want to cite eventually, and then download the whole thing or whatever?
We don't, and that's something that we were actually talking about, and it's sort of why I asked the question at the beginning, whether or not it's something that we want to roll our own or just provide better integration. So on the publication page, we do have the ability to take a formatted reference out. So we will integrate in with EndNote and most of the traditional desktop citation management systems. We do work quite well with Mendeley and Zotero. Mendeley has got a bookmarklet that will scrape the page and add the content in. So we're presenting the underlying HTML data in a way that they can scrape it pretty well, and same goes for Zotero. But we have talked about building some of that functionality in for people who aren't already using those tools. So, good question.
There's another question over here.
Hey, right now you're using Silverlight. So is there any plans to do HTML5 or something that's supported on iPad?
We are we're not putting any further investment in the Silverlight, and we're definitely going to be moving away from that from a cross-platform point of view. It is typically in those visualization views, so in the co-author graph, and I think we use it as well in the histogram for publications. So yes, we're looking at HTML5 definitely as a way forward for providing those visualizations.
Thanks.
Or you could get a Microsoft Surface when they're available. I think Scarlett's giving everybody one, right? Oh, okay.
Well, we'll consider. Any other questions? Perhaps on the use of the
feel free to ask. Yes.
Okay.
Yeah, thanks. I'm always very interested in if there could be a citation relationship presented. Like usually in some of the research area, there will always be some early papers, like only few early papers, and then there are some papers cite these early papers, and then a lot of papers derived from the paper. So it's like a relationship tree, something like that.
We are starting to do. Let me see if I can find a good example. So. Find something that's been cited well here. So we do provide a citation graph view in this. If you go to a paper publication page, I'm glad I wasn't doing a live demo. So here's something that's been cited 175 times. There's limitations in the sorts of visualizations that we are doing right now, and one of our Zoom interfaces in a related project is something that we've talked about doing that. If you could provide an all-up map on citations, but here is one of their documents that has been cited 175 times, and we do provide this citation graph view, just like the co-authorship graph. It's a way of, again, navigating through time, so we'll show the top N papers that cite this document and also cross citations between them, so you can actually see some of the self-reinforcing citation networks that go on in the space.
Can you also somehow tell the importance of the paper? Like if the paper is cited very many times, and then there's a different color showing out it's a very important paper that is very recommended that you read it. Something information like that.
It's a great idea, and we don't currently do that, but that's certainly something that we could do. And there's a number of different ways that we can do it. We do provide all of this data via an API. So anybody out there who wants to build some new visualizations or play around with this data, I'll talk briefly about the API and how you can get into that data as well. So you get the raw numbers, you get the citation counts, and then you get some of the aggregation views that we build in, like an H-index for a paper or H-index for a journal. So.
Yeah, my question was actually quite related to both of those answers about the API and the citation graph. One of the things that I found painful about Google Scholar and other similar tools is that they tend to show the citation count, but they don't show the references. So you see this kind of, you see the top of the tree, but you don't see the bottom of the tree.
Right.
And that's something that I would actually like to be able to see, is to be able to put together these sorts of visualizations, exactly what this lady was asking for. So is that available via the API?
Absolutely. So both of those are, so there's citation count, there's reference count, but then you can also query the API. You can say, for a given object, give me the items of type relation cited documents.
Okay.
So you can
so
navigate
you can pull out the actual
graph
references
that way.
and
Absolutely.
then traverse that tree.
Now, I'll put a caveat on that right now. We are consuming information into the index primarily today from paper information. And sometimes that paper information is PDF. And there's issues with us doing the entity extraction from unstructured documents. Increasingly now, we are starting to get XML representations of the papers from the publishers, which is nice. It makes it much easier for us to pull out references from the XML than we have been pulling out references from the PDF. There's another class of document that we get in that we have documents in our system that we only know about because it's been cited in another document. So we don't actually know where this document exists. Maybe it doesn't even exist on the web. It was a paper published 30 years ago, and it's still being cited. And you will see those in our graph here, and we just won't have a URL to get to the document. So in those cases, we may have only minimal information about the document being cited.
Are you able to feed this kind of information into the citation manager that Word uses?
Interesting question. We have done in the past. Actually, we had a prototype of this working. And Mendeley actually has done, I think, a better job than the Office team. This being recorded, am I going to get in trouble for that? No. I've told the Office team this. I've gone on record and said this. The way that Office works today is you have an Office-defined XML schema called the bibliography XML that is stored in the file system, and then they run a series of transforms over that data depending on the style. Zotero actually created this citation style sheets, essentially a CSS language for citation formatting, and Mendeley and a few others are starting to use that right now. And so the way that Mendeley has an add-in for Word, it sits right on the ribbon next to the built-in Word citation manager. And what they will do is they'll just actually write a JSON object into the Word XML, and then they allow you to go out onto the web. And they've got, like, Word ships with about 6 or 8 citation formats. And in the CSS space, there's a couple of hundred formats that people are creating. And so the Mendeley add-in will actually allow you to go out, browse those, search the 200 citation transforms, and cache those locally and change them within the document. So it's a little bit more robust. So we're talking with the Word team about the best way of doing that. Let me put it that way. Yeah. Oh, let me just. For posterity.
So, I mean, if a new paper just gets published, how long does it take to show? How long does it take you to show it in your system?
Yeah, very good question. Longer than it should right now. We're scrambling at the moment to accelerate the process through which we can bring on new publishers, and we end up having to write a separate connector for each publisher's format and the way that we fetch the data from them. And so we are, at the moment, updating most of the publishers probably less than once a month. And you'll actually see we have a little bit of stale data in the site right now. We're trying to accelerate that. So hopefully by our fall release, we'll get into a regular cadence, and each one of the publishers has a mechanism for us to either fetch their new content via FTP, or they can push feeds to us for indexing. So it's definitely, the freshness issue is definitely on our target critical path.
And second question, is it pretend to be like a free service, or after like the new release it will be like we need to pay for it or something?
We'll get everybody hooked on it and then we'll charge. No. It's definitely a free service, and will remain a free service. This is again, part of what Scarlett and my organization is trying to do is take research technologies and make them available to the academic community. So even though you raised a question about Silverlight, one of the things that you can do with the Silverlight visualizations is you can grab a little bit of JavaScript code. This is the Erdos number shortest path generator. That's the co-authorship graph. Each one of those things, you can take that code and you can embed it in your own website, and it will run queries back against our system. Or if you don't want the Silverlight dependency, you can just go and grab the author profile and a list of publications, and it will do a runtime fetch of that data from our site. Yeah?
You showed that you have a merge authors option. You have the opposite action, that you have the same author name. And it thinks that it's the same author, like we just saw it. And can you separate authors?
We don't currently have that. What we do have is if you go into the edit author UI, editing UI, we take all of the papers assigned to an author and we sort of put them into a yellow state. Like we think this paper belongs to this author, but it's an unverified state. And so what you can do for any author is you can go into that UI and you can flip them either into the yes or the no basket. And those then become claims in our system. You know, somebody has said that this paper is by this author. Somebody has said that this paper is not by this author. So you can't create a new author entity and say this paper, that paper. But when you do that second action, say no, this paper does not belong to this author, it puts it back into this orphan state, and it will then attempt to reattach itself to another author profile. Okay.
Right. Okay. Let Alex continue. But let me just say, at the time when I did my PhD, when I wanted to read a paper, I had to go to the library and find the conference proceedings, and then look through the conference proceedings, see other relevant papers, look at citations. Some of the proceedings had to be ordered in from the British Library, and it's just so amazing to see how kind of easy it is for you guys now. So who actually goes physically to the library to get some...
What's a library?
So it's amazing, and it's not been that long, right? So I think it's a great opportunity, but it's also a challenge because you have so much information to choose from, and how do you find your focus and drill down to actually what you need?
Yeah. Well, I will admit that I am actually a librarian. That was my college degree. Yeah. So this is me working on the next generation of library tools, I hope. The API, there's two options in the API for getting data out of the system. We've got a JSON interface, so you can pull back the JSON records. You can also use the SOAP interface. The only restrictions on the API right now is that it needs to be done for academic research, non-commercial purposes. So we do ask if you want to play around with the API, you can go to on our webpage at the bottom under help link, you'll find information about it, or there's a short URL here. We simply ask that you send us an email saying, I'd like an app ID that you pass in as part of your API calls, and you agree with the terms of use that you're not going to go and try and make money off of it. And beyond that, we ask if you're going to make a website that surfaces some of the information, let us know about it. We're curious. We're excited to have people use the data. Okay? Eigenfactor, I think back on one of your questions up here about citation information. Eigenfactor is a small group of people at the University of Washington who's actually doing some really interesting citation graph analysis work, and they've been using our API as well to look at a number of different things, but one of the things that they do is they can come up with paper recommender systems. They've got some interesting alluvial maps that look at the emergence of new domains. So when the domain of neurobiology came out, for instance, you can map then the feeder journals and the feeder domains. Where were people publishing before neurobiology came out that sort of started feeding into that domain? So they're actually doing a number of interesting investigations in this space right now, and we're going to start linking to a lot of people who are using our API and trying to promote some of the third-party research that's going on as well. In addition to that surface that Scarlett is going to give you, I think she's giving everybody a Windows Phone 7, aren't you? Yeah? If you have a Windows phone, we do have an app for the phone as well. And yeah, we'll skip that. So, quick call to action. Use it. Send us feedback. Let us know what you like, what you don't like, what you'd like to see. Do look up your record or look up your advisor's record and edit the record. Every edit into the system, like I said, helps us. It not only helps clean up that one record, but it actually helps us learn as the algorithms go in and take those statements of fact. Even if you look at your profile and it looks like we have most or all of your publications there, go into that profile and move those things from the yellow status into the green status. Say, yes, that is my publication. So again, that helps cement those things together. And helps our algorithms learn. Mention the API. Spread your word, follow us on Twitter, and let us know what you think. All right?
Sounds really good. And I think everyone really thinks now that I'm really ancient, which is probably true in comparison to you. But we have this afternoon tomorrow where we'll have historic talks of Tony Hall, who did the quicksort bubbles that probably about 50 years ago. So consider what computer science was like then, and you'll get a bit of a glimpse of that tomorrow. But yeah, it's really fantastic technology. So
Good, thank you.
So I hope you kind of try it out. And I certainly looked for myself on there, and I did find myself, which was good.
Well, I searched you the other day, and we actually found you in your pre-married name as well, so I had to merge those records
so
together.
You've linked that together.
Exactly.
Any more questions? No.
Well, good. With our remaining 11 minutes, let me show you one more thing just to whet your appetite. So everything that I told you about academic search is something that we've been doing with our own internal researchers and internal engineering team. I also mentioned that we do a lot of collaborative projects with universities. And so one of the projects that we've also been working on, the bulk of the development is being done by students actually at Moscow State University, and the bulk of the requirements gathering is being done by UC Berkeley, and we're sort of acting as brokers and technology advisors, and we do a little bit of the code writing. But this is something that Walter Alvarez from UC Berkeley came to us with about 18 months ago, and he's a paleontologist, and he's been teaching in the area of what he calls big history. He was tired of people claiming that history was something that lasted, 2,000 to 6,000 years, and it was essentially human history. He was saying, no, paleontology is history, geology is history, astrophysics and the birth of the galaxies is all history. And he wanted to find a way to demonstrate the relatedness of all things time-based in a single massive timeline. And so we worked with him, and we brought in some of the people from the product teams who had been working on deep zoom technology. And again, deep zoom was based on Silverlight as well. And we said, we want to do what you're doing with Silverlight and deep zoom, but deep zoom at the time could only take you about 8 or 10 levels of zoom deep. And we needed to be able to go from 13.5 billion years of the universe down to Planck units in a single slidable scale. And it wasn't something that they could handle. And we said, oh yeah, by the way, and we don't want to do it in Silverlight either. We want this to be done all in HTML5. So we jointly built this project. This is an open source project. The code is all freely available out on the web. I think it's under an Apache 2 license. And you can zoom on this timeline down into human prehistory. And the whole point of this is that it becomes an infinite canvas for hosting rich media. You can put movies into this. In fact, you can just expose movies that are out on YouTube or Vimeo directly within this UI. You can put content, you can put images, you can put documents. And in my last attempt at a live demo here, you can then zoom down in. So this is the 5 billion years of Earth. This is the history of life on Earth. This is the zooming in of human prehistory. And this is humanity. So a very small sliver of time. We only have a few thousand, 10,000 or so content objects in our database right now, and all this is being hosted up in Azure. We want to have the option for people to federate out to multiple content sources like we do with the videos right now. The reason that we're trying to bring all the content in is because one of the next things that is enabled in this environment is the ability for people to come in and to create tours of data. So, come in here. This is a student at UC Berkeley who's created a tour about the Japanese-American internment.
My name is Leslie. I'm a third-year psychology student.
And she put the content into this. She's telling the story of her grandparents, one of whom was Japanese-American. And
let me take you on a brief tour.
The whole point of these tours is that somebody can describe their way around the content. They can tell a story.
The story of a married couple,
and I can pause it.
Will be used to help understand internment.
I can't. So I can pause that. I can either listen to her story, or I can go in and browse around this content myself. And if I want to go in and look at an individual document, I can do that. If there's a movie, each one of these content bubbles here has a bibliography of information associated with it. So you can actually put in the full text of documents it allows somebody to get sort of a 5-minute narrated overview of it, but then it also invites people going off on tangents and exploring and discovering new things. And because we're building this tour mechanism into this, we want to get the bulk of this content up onto a stable environment where we know where it's going to be. And then that all fades back in. So this is the ChronoZoom timescale project, and something that we're very excited about the direction that this is going to go. When you talk about citation graphs and looking at citations over time, we've also talked about taking the millions of papers that we have in academic search and presenting them in an interface like this. You can actually browse through to the full text. So
where is the blind scale?
When you actually go into the Big Bang history here, I don't know exactly where it is, but you can actually drill down into the first few milliseconds of the Big Bang, and they can start tagging content at that level as well. So, all right. I think with that, I will.
Do you, Alex?
What's that?
You don't have the video about it, but.
Of this?
Yeah.
So the video of ChronoZoom is actually in the application itself. The question is, do I know where it is? David Christensen from Australia, and I guess I could look at it here. Let's go here, and introduction to ChronoZoom. Now we have to zoom all the way back to now. So you guys can play around with this as well. This is Walter Alvarez, and you can jump these into full screen mode as well. I think I'm running off the wireless here, which is why my demos have been.
My name is Walter Albert.
Yeah, probably not a good idea to do a video. But do play around with it. These are the students at UC Berkeley and Moscow State University talking about their efforts. A lot of the great visualization stuff was all done by Moscow State University and creating that nice seamless slide in between billions of years.
Yeah,
okay.
So that's one of the examples of the great engineering work that's happening in Redmond.
And Russia and California, yeah. All right, well, thank you all very much. Yeah, more questions?
It's like sometimes different people have different view of how to write history. I mean, is it like, I feel sometimes it's controversial if you are trying to, I don't know, it's like, I'm not having an example in my head, but like, you can read about different, the same kind of occasion happens like 20 or 50 years back. Two different books are putting it in two different ways. So, I mean, how you are solving this?
We're not solving it. Definitely not solving that problem. But that's a great point. In fact, this is one of the areas where we want this to be a tool for looking at some of the differences. So let's not talk about human history for a second. Let's talk about something less contentious. When you look at something like the evolution of life on Earth, you can play around with the, that's humanity, and there it goes. You can play around, we have built in, I don't know where it is now, may not be in the tool yet, but we built in a tree of life, effectively, that starts from the universal common ancestor, the start of life on Earth. And then as you go down the tree, the one that we surface in the UI here is the one that eventually leads to mankind. There is, I was going to say a controversy. Controversy is not the right word. There is a difference of opinion about the rate of change, and we don't have a lot of data about it. And so the typical tree of life will basically say, we know that this is roughly the point in time where the universal common ancestor was, and we know of these multicellular organisms here, so let's just project out a common rate of evolutionary change over that time. Other people have said, well, no, hang on, there were probably little blips of like more rapid evolution, and so the idea is to be able to put up competing theories side by side and say, here's one way of looking at the data, here's another way of looking at the data. The other example that we actually had in the prototype of this was the point at time where they believed that the Mediterranean Sea had effectively dried up. And this was in sort of early human history, so there were stories of when this happened, but then there's also geologic record of when it happened. And there are third records from elsewhere in the Mediterranean that conflicted with both of those. And so by bringing all three of the geologic record and then the fossil record and the human history stories together, you could see that these events were not aligning. But that's one of the sort of exciting things about this tool, is that it can be something that's used for education, used for teaching purposes, used for exploring differences of different theories. So we're not going to be the gatekeepers of what is the right content to put into this. Up here.
Hold on, guys. We have to run down.
Yes.
Is there a way how I can actually skip the animations? Like, I can somehow list through it more fastly. I mean,
you want to zoom faster?
Yeah.
You can search, and so all of the elements are available via the search tool here. So if I wanted to search for, I don't know what's a good example, but this will drop you into specific ones. I think this is still going to zoom you between the elements. Yeah, it will. So I guess the answer is no. You can't skip those. Just look away for a couple seconds. Does it give you vertigo? Oh, that's okay. Yeah.
So I think having facts is neat, and ability to zoom on them is very nice. But what's important, I think, is having relations to them or between them, and also providing context. So, for example, if there is a historical event, it's much more important what was happening around that event, not just the event itself. So, is there a way to?
So in this version, that's not there yet. But the general idea was to be able to effectively pin the elements that you wanted to look at. So if you're looking at World War II, there's a section in here on World War II. But if you wanted to look at the world economy and sort of pin that timeline, or specifically about some of the I'm making this up as I go along, but you wanted to look at the state of California and the laws that were being instituted in California compared to the federal interment, and look at these things side by side, that you could essentially put together your own timeline of the bits of content. The only way of building the relationships right now is by putting a tour together and essentially narrating that and saying these things go together, and you give a verbal story. But from an exploration and a comparison point of view, yes, we want to be able to provide that level of integration.
Yeah, I can easily imagine some kind of indexing that would automatically provide relations, just as the academic tools do. So based on some keywords or something like that.
We certainly could look at that. Let's talk more about that today.
All right.
Okay,
thanks.
there were 3 more hands going up, and these will be the final questions.
And then time for tea.
Yeah.
So I have 2 very short questions. Actually, they are related to each other.
Okay.
First, how do you define the granularity of the event? So how do you decide an event is important or unimportant? The second question will be, do you also have content about very recent events like 2012 French elections, like this?
So the answer to that second question is no. And one of the challenges that we're facing right now is we as Microsoft Research are not going to be the ones who control what content goes into this database. And in the long run, we want to have a large enough data set of sort of background content. So we're working with a number of cultural organizations, the Smithsonian and National Geographic, and we've talked to Wikipedia and others just to get some base content in. In terms of the granularity, it almost doesn't matter. I mean, we're targeting actually very highly visual content right now. So where we've talked to the Smithsonian about images of Native American pots that we actually want to put in as part of a Native American collection. This is a very visual tool, and even though we have sections in here for text and for bibliographies and for doing deeper research, this is still a sort of high-level high-level data visualization. Now, that said, there isn't anything that prevents us from getting very, very precise. And so in the long run, we do want to have a federated architecture where you can take your own data. And if you are specifically looking at something very, very precise and you want to put individual data points, data elements into this into the graph, you can do that as well.
How do you avoid spam in crowdsource editing?
In academic search, right now, we don't have a mechanism that scales very well. We have a team of editors who reviews all of those edits that comes in. And that's one of the reasons that we require a live ID login.
So instead of requiring a live ID login, which anyone can get, why don't you resort to official ID, like academic ID of a person, and map it to the papers? In the paper, there's an email ID given, right? Why don't you?
Yeah. So we are actually members of the ORCID effort, which is the Open Researcher and Contributor ID project. There's also an ISNI effort that overlaps with that a little bit. ORCID is just coming online right now, so nobody actually has one. So we are looking at a way of integrating that and actually possibly providing some way for people who either have one and don't know it, or don't have one, going to a profile record and saying, that's me. We'll ask for their ORCID, and if you don't have one, we'll redirect you through the ORCID site to get one generated, and then we'll attach that to the record.
Okay, last question then.
Could you please tell me how do you clean the content, how do you prove that the content is correct, and how do you add it automatically or manually into the system?
Sorry, Chronozoom or academic search?
In the Chronozoom.
In Chronozoom? So right now, all of the content that is coming into us is curated content, and this is mostly being handled, had been being handled by UC Berkeley. We're actually now partnering with the library system at the University of Washington and the library school there, and they are going to be providing the ingest for the background information. So we're going to have this sort of two-tier set of information, one of them being the body of curated content that we bring in that anybody can party with and is stable within Azure, and then the other is the more transient data that anybody who is playing around with the application can say, I want to take my data, cast it up into here, and create a tour for that. But we then don't have any guarantees that that data stays around if you move it off of your server.
How do you solve the problem of different points of views on the one problem? For example, the theory of the beginning of the world. There are several of them.
Yeah, so we're not, like I said, we're not solving that problem. We're providing a platform for exposing multiple points of view. So you would go, if you wanted to go and talk about, the first 3 seconds of the Big Bang, then we will provide the mechanism within that environment for actually lining up multiple points of view and looking at the differences of that. Yep. Okay. You can't say anything that happened before that, though. You can't go back pre-Big Bang.
Thank you, Alex. That obviously created a lot of interest and questions.
Well, I hope
you haven't got a
you will
hole in your tummy now because of all the questions.
I hope you guys will all play around with the tools and take the source code for Chronozoom if you want to do further explorations on what we've done with HTML5 there. So enjoy the rest of summer school. Thank you.